Good day, Miss Daisy. My name is Leo Vicamburnero and I'm joined by Mr. Jean Francis Palma, and we are here to present our Dismath CAPSTONE applications of trees in real life. So, without further ado, let us all welcome Mr. Jean Francis Palma to explain the first part of our capstone.
For the purpose of this project, we had opted to use the root of the tree, as it is a connected acyclic graph with a special node that is called the root of the tree, and every edge are directly or indirectly originate from the root. Now moving forward to the family tree of Mr. Leo Vicamburnero. Unfortunately, since his family originated from the Bicol region, we haven't had the chance to inquire about his great-grandparents and great-great-grandparents. What we have here now is his grandparents to his first cousins. His grandparents being Miss Pedrina Lorigas and Federico Lorigas, and their four children, his mother, Miss Leos Lorigas Cambronero, and his uncles and aunts, Mr. Bajon Lorigas, Mr. Badal Lorigas, and Miss Alice Lorigas Colendra. His cousins from Mr. Bajon Lorigas and Miss Jenny Lorigas being Jessa Lorigas, Charlotte Lorigas, Journey Lorigas, and Angelita Lorigas. His cousins from Mr. Badan Lorigas and Miss Ana Feliz Lorigas, Mark Lorigas, and Jongjong Lorigas. His cousins from Elise Lorigas Colendra and Mr. Eliano Rico Colendra, Elrico Colendra, and Erica Colendra.
And now we are here for the arithmetic expressions in a tree structure, on where we're gonna convert this arithmetic expression into a tree structure. Specifically, the tree structure that we're gonna use is the binary tree. So here we have an expression of quantity 3 times 6 plus quantity 5 minus 2 divided by 3, quantity minus 8 plus quantity negative 5 times 2 plus quantity 6 minus 3 divided by 1 quantity. So that is an expression that is now going to be converted into a binary tree. So first, let us see what is the process. So here we have on how to solve this kind of expression and to converting it into a binary tree. So first we have is the rule on where the operands such as positive or such as plus, minus, times, and divide is going to be considered as the parent node of what is being performed, or what are the involved constants that is being performed in an operation. We also have as well the PEMDAS rule, which the parentheses expression, the multiplication, divide, addition, and subtraction. We will follow that method in order to solve to convert these arithmetic expressions into binary tree. So here we have first is the parenthesis equation inside this expression, the 5 minus 2. And here our operand is a subtraction. So that subtraction operand is going to be our parent node for the two constants 5 and 2. And to determine where those constants will be placed, we just have to look where it is placed on the operand. So here we can see that 5 is placed at the left side of the operand minus. So we put it at the left side, or we put that node on the left side from the parent node. And here we have 2 that is located at the right side. So we locate it here at the right side of the tree, or from the parent node. So that is the basic explanation here. Now we ask, what if we have another operand here? Now we have two expressions. Here we have a binomial and a constant. So we just look at once again what is the operand that is between two expressions, and that is the divisor here, the divide operation. So that is going to be our root node or parent node. And now we see that number 3 or the constant 3 is at the right side of this operand. So we just traversed it towards the right side, and we just put that node here, the number 3 at the right side from the parent node, the divisor, and then we just put here the 5 minus 2 or the quantity of 5 minus 2 at the left side of the operand divisor, which what we solved earlier. And then we proceed here. Now we can see that we have two expressions that is being separated by a plus operation here. So now we have the expressions 3 times 6 and quantity of 5 minus 2 divided by 3. So what we do here is that we use this positive sign or the plus operand as our root node, and we traverse towards left. And what is the expression that is on the left? That is the 3 times 6. And once again, as I said, we use those operands as the parent nodes for the constant. So here we have the operand multiplication and should bear the child nodes 3 and 6 respectively, left and right on where it is placed. So 3 is located at the left side of the multiplication sign and 6 is located at the right side. And here we solved already this one earlier. We're just gonna implement that here at the right side of the operand addition. So here you go. That should be for the left side expression of this whole equation that we have here. And then we're just gonna do some brief review here as it is the same. Here, we're now solving for the right side. So, should be that you understand this already on what happened here. And here as well. So, it's just almost the same. The difference here is that we have now a negative 5. So, what do we do with that? Here we have the negative sign towards the number 5 or the constant 5. So we just treat it as well as an operand. So that is a subtraction sign. So we put here the subtraction sign as our parent node for that node that is going to contain the constant 5. So where do I place it? So we place it, so as you can see here, it is in the right side of the operand negative or subtraction. So that's what we're going to do. We're gonna put the number 5 node here at the right side of the parent node subtraction. So that's how we deal with cases such as we have negative signs. So that should be understood. And here it's just an application once again of the negative sign. We have here the positive or the plus operand as our operation that is dividing the two expressions. And here we just apply what we learned to how to deal with negative signs on constants. So here we have the negative sign as the parent node of the node that will contain the constant a. So there you go. And now we proceed here, and this is going to be the final answer for that node. Here you can see all the solutions that we did earlier, and there you go. And now we proceed on how we traverse this kind of tree. So this is a binary tree once again. So now let us start with in order. So in order, we have the nodes that should traverse first towards left, then print, then right. So how does it work? Let's start with the root node, here the positive sign or the plus operand. So by what the in order does, we go first at the left. We traverse towards its left, and now we are here at the subtraction node. And now what is next? We traverse once again towards left. Here we have now we are located here at the node that contains the positive. And then we traverse once again as it can still go to the left. We are now here in the multiplication node and traverse towards left once again as we can still traverse, or we still have a path towards left. Here now we are now in the node with the constant 3. As you can see, it is a leaf node. as it doesn't have any child nodes anymore. So it can traverse towards left or right. So now we just print it out. That is the first equation here, or the first value here, the 3. And then now we go back to the parent node of that 3, which is the multiplication sign, and that is the times. So now that we already traversed to left, we now can print. This is the RT, the root. We can now print the multiplication sign and then traverse towards its right. If there is a right path, here we have number 6, the constant 6, which is once again a leaf node. So we can just put it here on our final answer. And then we traversed back into the parent node of the multiplication, which is the positive or the plus operand here. So we apply the same scenario here, that it already traversed towards left, so now it can be printed out. And then we traversed into the right, and here we see that the divisor can still travel towards the left. So we are now here in the subtraction node, and then we can still traverse to the left, and here we are met with a leaf node. So since we know that this is a leaf node already, we can traverse to left or right, we just print it out. And then we go back to the parent node of that constant, here the negative, which already traversed to left, so we can print it out already, and then traverse to its right, where we meet once again a leaf node, and we can just print it out. And now we go back to the divisor that is already traversed to left, so we can now print it out as well and traverse towards right. And here, the constant 3, or the node 3, is now once again a leaf node, so we just print it out. And now we go back to the parent node of this divisor, which is the positive, but this already has been visited, so we go back to the parent node of that positive, and now to the negative or the subtraction here. Here in the subtraction, it already traversed to the left, so we can now be printed out, and then traverse to its right, where we can see where we will met once again a leaf node. So we can just put it out, print it out, then go back to the parent node. Since the parent node of the 8 and positive or the addition already has been visited all the requirements, it can now go back to the root, the main root of the tree, which already traversed to the left. So what is left to do here is to print it out. So it's the same with the right side of this node. So that is for the in order, and you should get 3 times 6 plus 5 minus 3 divided by 3 minus 8 plus minus 5 times 2 plus 6 minus 3 divided by 1. So that is our for in order. Then what about pre-order? Here in pre-order, we just print, go to the left, if go to the left, print, go to the left, print, go to the left, print. Then after we do everything that is on the left, we now print the right. So we're just gonna speed run this one, as pre-order is probably the easiest one. So we see the node plus, we print it out, go to the left, now we see a subtraction node. This node gets printed out as well, then go to the left. We traversed already here, now we can print it out, then go to the left. We see the multiplication sign, operand. This node gets printed out, traverse to left. And then we go to the tree, number 3, which is a leaf node, so we just print it out. Then now that we already traversed towards left, we can now go back, or we can now traverse to right. Here we have number 6, so we print it out. Then we go back to the plus operand, and we traverse to the right, and print out the divisor. We traverse towards left, and print out the negative, or the subtraction. Traverse to the left, and print out 5. Since we can't go to the left anymore, we now traverse towards what is left in the right. Now we still have 2. Then traverse from the operand divisor towards 3. Print it out. Go back here at the minus or the subtraction. Traverse towards right and print out the 8. And then just repeat the process for the right side of our tree. So that is the pre-order and probably the easiest one. And now we go to the post-order. In the post-order, we traverse first the left and right before we can print. So every node should first visit its left side, its right side before we can print it. For example, here in the left side of our tree. So first we have the root. We traverse first to the left. And as you can see, we can still traverse to the left. and once again to the left, and I'm now here on the multiplication node and traverse towards left. And we can see that 3 is once again a leaf node, so we can just print it out. And then we go back to the parent node of number 3. But here, we don't print out the multiplication yet. We first traverse to its right. And you can see here the constant 6 is a leaf node, so we just print it out as well. And then we go back to the multiplication, and since it already traversed from left to right, we can now print it out here in our final answer. And then we go back to the parent node of that multiplication, which is the addition here. And then we're still not gonna print it as it still haven't traversed towards its right side. So we now traverse towards right, and now we meet the divisor. And then we traverse towards left, as there's still a pathway towards left, and then we're now in the subtraction. And then traverse once again to left, as there's still a pathway. And now we are met with a leaf node, which is number 5, so we print it out. And then once again, we're still not gonna print out the negative or the subtraction. We're gonna traverse first to its right, which is 2, print it out as it is a leaf node. Then now we can print the subtraction. And then go back here at the divisor or the divide operation, and then go to its right here. And the number 3 is a leaf node, so you just print it out. And now we can print the divide operation. And then we go back to its parent node, which is the addition. Since this addition already traversed from left to right, it can now be printed out. And then we go back to its parent node, which is the negative or the subtraction. This subtraction still haven't traversed to right, so we can print it out. We go first to its right side. Here we are met with a leaf node of constant 8, and we print it out. And then we go back here to the negative, which now traverse from left to right, and now we can print it out. And then we go back to the root node and traverse to right, and the same process repeats. As the post order, it's going to be that the final value that we're gonna get should be the root node. So this is the final answer you can see on the screen, and that is it for the in order, pre-order, and post-order of the expression that we just converted to binary tree. So I hope you understood our lesson here. Thank you, and this is the presentation of Mr. Jean Francis Palma and Mr. Leo Vicambronero for the Dismath Capstone 2023. Thank you.